In this video, we're going to talk about standard deviation. So, in concept, standard deviation is a way of measuring the variability of the data. So, here, I'm going to write that down. I actually left a space between this and the example. So, it will measure the variability of the data. Now, variability is a little bit of a subjective term. Variable with what? With each other? Probably. But what we'll use is the concept of a central measurement, which we talked about previously when we talked about averages. Okay. Before we do that, let's look at this example. And if you need to pause the video to write this down real quick before I continue, that's fine. But let's kind of look at this data in terms of how spread out it is. I'm going to actually take a second and draw a number line here and graph this data. So it looks like my smallest value is at 40. My highest value is 88. Okay. So I think it'd be reasonable to maybe go by tens. So 50, 60, 70, 80, 90. Okay, see, I definitely don't need all that much. Okay, that's fine. Great. So here, I'm going to graph this data. So 58 would be like right about here. 88 would be pretty close to here. 40, 60, 72 would be right about there. 66 would be a little over halfway. 80, and then 48. Okay. So here's the data. We can kind of see how spread out the data is, right? We have values from here to here. And that is information, but really it doesn't measure much of anything. So as I mentioned, we're going to use an average to be our comparison point. They call that a measure of center, okay? But let's go ahead and use the average we're probably most keen to use. That would be the mean, all right? And let's find the mean for this data. So I am going to find the mean. Now, I didn't introduce this notation last time, but I'm going to go ahead and introduce it this time. One way we can represent the mean is an X with a bar over it. That typically in math is representing the mean of something. Okay, so I'm going to go ahead and add the data together. I'm going to write out what I'm doing though. So I'm going to write out all the data values. 60, 72, 66, 80, and 48. And you should go get your calculator so you can do this with me. There's 8 data values here. So I'm going to add those all together and divide by 8. Now, I did already pre-add it, but like I said, grab your calculator, add along, do this with me. It's good practice for you. Pause the video for a second. When I add it up, I get 512 divided by 8, which is 64. So there is my mean. Okay, so now let me go ahead and draw that on my graph here, okay? So 64 would be probably somewhere around in here. Here is the mean. And when I kind of look at it like that, now it looks like I'm kind of splitting the data a little bit in half, right? I'm going to go ahead and erase my little top bar here so not to confuse us. We're kind of splitting the data a little bit in half, and we can kind of see how far the data values are from the mean. And we notice that there's quite a few very close to the mean. There's a few that are a little bit smaller. They're smaller than the mean, bigger than the mean. It's split in half. See that? 4 of them are smaller than the mean. The other 4 are bigger than the mean. So the mean is kind of showing us relatively where the center of the data is and how spread out the data values are from the mean. That's what we're interested in looking at. And that's what the standard deviation is going to measure for us. So loosely, the standard deviation is going to measure the standard deviation is the average distance a data value is from the mean. And to do that, then I'm going to actually need to take each data value and figure out how far away it is from the mean. Okay, so basically what I'm going to do is I'm going to take each data value, and here I'll call those data values X. So these data values, we're going to call them X. So what I'm going to do is I'm going to take each data value and I'm going to sorry, I'm looking at the formula really quick. I wanted to copy it properly. There we go. I'm going to do X minus X bar. And then what I'm going to do with that data is I want to add them all up with the other differences of data. But before I can do that, it becomes a little bit troubling. So leave a little space here, and I'm going to introduce the formula in a second. I'm going to go ahead and show you what those differences look like, okay? And then I'm going to talk about the problems that we're going to face and why we're about to do what I'm going to show you. Okay, so here, give yourself some space. Like I said, I'm going to introduce the formula in a second. I'm going to create a little table here, and I'm going to create a table of the values that we had for the roller coaster. So here, I'm going to rewrite it right here for us. So we had 58, 88, 40, 60, 72, 66, 80, and 48. Okay, so here, I'm going to shift my screen up a little bit. And what I'm going to do is I'm going to take each data value and subtract the mean. Now, remember, the mean came out to 64. So I'm basically going to go through and I'm going to do each data value minus 64. I'm grabbing my calculator. You grab your calculator to do this with me. All right. I don't need this much of a table. Sorry. I just realized that. Okay. So if I subtract 58 minus 64, I get negative 6. 88 minus 64 gives me 24. 40 minus 64 gives me negative 24. 60 minus 64 gives me negative 4. 72 minus 64 gives me 8. 66 minus 64 gives me 2. 80 minus 64 gives me 16. And then last 48 minus 64, I get negative 16. Okay, now I just finished saying that I want to take an average of these. And there is a big, giant, huge math problem. And that is that some of them are positive and some of them are negative, which means they're going to cancel out. That's the problem. I can't do that. Now, there are a couple of solutions. One solution is to take the absolute value, right? Get the positive number for each of these. If you were to do that, that would be called the mean absolute deviation. And there is a place for doing the mean absolute deviation. The mean absolute deviation is when you take the absolute value takes the absolute value. And I'm talking about like the absolute value is the distance value is from 0. So the absolute value of 6 is 6, and the absolute value of negative 6 is also 6 because they're both the same distance from 0 on the number line. So we can go through and take the absolute value of all of these, okay? And then add them up and divide by how many there are. All right. But that actually is mathematically a problem. Absolute value poses a big problem in math. So instead, we're going to do an alternative solution. I'm going to square each of these values. I mean, literally raise them to a power of 2. I'm going to square each of these values. Sorry, my computer froze there for a sec. Come on, wake up. Okay, there we go. Okay, I'm going to square them, add them together then, because when I square them, they're all going to become positive. And then I will take the square root to undo the fact that I squared it. Okay, so I'm going to square and square root. So remember, square and square root like undo each other. If you square something and then take the square root, they basically start back to where we began. So here, let me give an example. Not two, because there's too many twos. 3. 3 squared is 9, and then the square root of 9 is 3. So a square and a square root basically just cancel out. I could have just, rather than actually go through the process, just erased them and said, that's just 3. Okay, so we're going to use that mathematical property instead. So let's go through and square each of these. Basically, we're multiplying by itself. So -6 times -6, well, I can do that in my head. That's 36. However, I can't do 24 in my head. Positive 36. Sorry, -6 times -6 is positive 36. 24 times 24 is positive 576. And so is -24 times -24. It's also a positive. -4 times -4, that's 16. 8 times 8, or 8 squared, is 64. 2 squared is 4. 16 squared is 256. And same with -16 times -16 is also 256. Cool. Okay, so here's what we're going to do. So I'm just going to put up here in my formula that I squared them. All right. And now I'm going to add these up. And the math symbol we use for sum is a giant sigma. This means sum. All right. So I'm going to add these together. Ooh, okay. All right. Figure out what that gives me. Okay. Okay, so I got 1784 when I added those together. Okay, now, before I take the square root, I'm going to go ahead and take the average, meaning I'm going to divide by how many data values there are. Now, in this problem, there are 8 data values. And we use n to represent the number of data values. So n equals number of data values. Oh, sorry, can't spell. Values. There we go. So in this case, n equals 8. There are 8 data values. But the formula actually doesn't do that. The formula actually divides by n minus 1. I'm not going to get into why. It's not really important, okay? It does have to do with the fact that there are 2 different types of standard deviation, but n minus 1, it's fine. That's what we'll use. So we're going to take 1784 and we're going to divide it not by 8, but by 7. And from that, I get a huge decimal of 254 point, let's say 857. I'll go some decimal spaces out there. Now we're going to take the square root. Now we're going to take the square root. So I'm going to go ahead and I'm just going to insert the square root at this point. And I'm going to use my square root on my calculator of my answer. And I get 15.96. And that is my standard deviation. So I'm going to come back up to my formula here. And I'm going to take the square root of this. That is the standard deviation. All right. It is the square root of the sum of x, each data value minus the mean, squared, divided by n minus 1, where n is how many values, data values there are, minus 1. And that finds this average distance the data values are from the mean. Now, I did a little bit of kind of trust me, just believe me, but we're saying that on average in this set, the data values are about 16 away from the mean. That is what the standard deviation is for these problems.